In this video, we're going to talk about square roots, rational numbers, and irrational numbers. Square roots have a symbol that most of us have seen before, and it kind of looks like a division sign, but it's slightly different. It's going to look something like this. And when we're talking about square roots, you're going to see that there's always a number inside this little symbol. So I can put, for example, 16 here. And this question would be asking me, what's the square root of 16? And that's basically asking, what number times itself gets me 16? So if I think about it, 2 times 2, that would only get me 4. 3 times 3 would get me 9. 4 times 4 gets me 16. So I can say that the square root of 16 is 4. There's many numbers that we call perfect squares, and here's what they are. So 16 is actually a perfect square because I can achieve 16 by multiplying an integer by itself. So if I think through my perfect squares, 1 squared, or 1 times 1, would be 1. So that is a perfect square. 2 squared, or 2 times 2, is 4, so 4 is a perfect square. 3 squared, or 3 times 3, is 9, so that is a perfect square. And I can keep going with this forever pretty much. The 13 perfect squares that we use the most often are the first 13, and there is a spot for this on your note sheet. So we have 1, 4, 9. 4 squared is 16. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared, 144, and 13 squared, 169. And again, these are all what we call perfect squares, because when I take their square root, I get a whole number answer. Now, there's a lot of other numbers. Let me get my pen here. Let's say I asked for the square root of 2. Okay, now 2 is not a perfect square. So when you find the square root of it, it's actually going to be some long decimal answer. And for those, for right now, we'll be using a calculator. Another example of one that is not a perfect square would be the square root of 10, because there's no number times itself that will get me 10. So keeping that in mind, we're going to talk about these two terms. You're going to hear them a lot this year. And the first one is a rational number. A rational number is a number that can be written as a fraction. So that includes numbers such as 2/3, which are already in fraction form. It includes terminating decimals such as 0.7, because I know that I can write 0.7 as 7/10. It also includes repeating decimals that have a pattern to them that I can use a repetition bar with. So 0.3 repeating would be a rational number. Any whole number, maybe 256, would be rational, because I know I could take a whole number and I could put it over 1 in order to make it into a fraction. So these are all my rational numbers. I also have irrational numbers, which are the opposite, and these are the ones that cannot be written as a fraction. So for example, pi. Now we know pi is some long crazy decimal. There's no real pattern to it. You can't predict what comes next. So I wouldn't be able to make that decimal into a fraction. Another example, we talked about square roots, right? So any square root that is not a perfect square, so the square root of 15. If you put that in a calculator, you're going to see you get a long decimal that doesn't necessarily repeat in any way. So that would be irrational. Thinking back, I should put the square root of a perfect square here. So let's use the square root of 25. Okay. Our irrational numbers can also be some interesting decimals such as this, 0.10, 1, 1, 1, 0, 1, 1, 1, 0, and so on and so forth. Okay, so this is a decimal that never ends, but again, I can't use a bar notation on it, so that would also be irrational. At this point, please make sure you have filled in your notes and let me know if you have any questions.